mo kí gbogbo olólùfẹ́ Sanfatis TV káàkiri orígun mẹ́rẹ̀ẹ̀rin àgbáláyé. A dúpẹ́ lọ́wọ́ yín bẹ́ẹ̀ tí ń pín gbogbo fọ́nrán wa káàkiri tẹ̀ tún subscribe sórí péjì wa káàkiri ayélujára. A dúpẹ́ o, gbogbo ibi tẹ́ ẹ ti ń rí owó Ọlọ́run ní jẹ́ ó tán bẹ́ẹ̀, gbogbo ibi tẹ́ ẹ ti ń rówó ra dátà àpò yín ò ní gbẹ. Ẹ bá wo fọ́nrán tá a fi sórí ìkànnì ayélujára ti YouTube wa láàárọ̀ yìí, èyí ló ń sọ fún wa nípa ọ̀nà ìgbàlódé, ọ̀nà àrà ọ̀tun tí àwọn òyìnbó tí wọ́n ń gbà cultivate, tí wọ́n ń gbà gbin ẹ̀gẹ́, tí wọ́n ń gbà láti ṣe gàrí, tí wọ́n ń gbà láti ṣe fùfú, tí wọ́n ń gbà láti ṣe gbogbo ohun tó jọ mọ́ nǹkan oúnjẹ tó jáde látara ẹ̀gẹ́. Wọn ò lo ọwọ́, wọn ò lo nǹkan kan míì tó jọ mọ́ ẹ̀rọ ìgbàlódé lọ tí àwọn olóyìnbó ń pè ní machine. Èyí jẹ́ nǹkan tó jẹ́ development tó lágbára gan. Màá fẹ́ kẹ́ ẹ wo fọ́nrán yìí dáadáa, ṣùgbọ́n ẹ jẹ́ n ṣàlàyé tí ń bẹ́ẹ̀ gangan fún yín. Bí àwọn òyìnbó ṣe bẹ̀rẹ̀ láti máa gbin ẹ̀gẹ́ níbi tí ó rọ̀ wọ́n lọ́rùn dé, òun ni ẹ máa wò lórí fọ́nrán yìí. Ẹ wo bí wọ́n ṣe ń gbìn. Wọ́n gbìn, nígbà tán gbìn tán, wọ́n tún lọ sóko. Lẹ́yìn ìgbà tó lò bí oṣù díẹ̀, wọ́n lọ sóko, wọ́n lọ kó ẹ̀gẹ́ yẹn wálé. Kìí ṣe ọwọ́ náà tó fi kó ẹ̀gẹ́ o, wọ́n fi ẹ̀rọ ìgbàlódé òní wọ́n fi kó wá sí ilé iṣẹ́ wọn. Nígbà wọ́n wá kó dé ilé iṣẹ́ wọn tán, ẹ wo bí machine bó ṣe ń bó èpo ẹ̀gẹ́ láì ṣe pé wọ́n lu ọwọ́, níbi tó jẹ́ pé bá ṣe ń bó yìí lọ́nà tó jẹ́ wípé ó gbà yájú ní àgbáyé ni. Bí ẹ̀rọ ìgbàlódé bó ṣe ń bó ẹ̀gẹ́ yìí, bẹ́ẹ̀ náà ni wọ́n tún ṣe kíni, bẹ́ẹ̀ ni wọ́n ń fọ́, bẹ́ẹ̀ ni wọ́n ń lọ̀, bó ṣe ń lọ̀ bẹ́ẹ̀ ni wọ́n ń yan. Ẹ wo gbogbo àwọn machine tẹ́ ń wò yìí o, iṣẹ́ ìgbàlódé, iṣẹ́ òun àrà ò ní wọ́n ń ṣe. Ẹ̀rọ ìgbàlódé tí wọ́n ń lò yìí ó jẹ́ ẹ̀rọ ìgbàlódé tí kò mú wàhálà kankan lọ́wọ́. Ẹ̀rọ ìgbàlódé tó jẹ́ wípé bí ẹ bá ti mọ bí wọ́n ṣe ń lò ó láti ìbẹ̀rẹ̀ títí dé òpin, á jẹ́ kí iṣẹ́ kó rọrùn fún yín, á jẹ́ kí inú tiyín gan dùn láti ṣiṣẹ́, tó sì jẹ́ wípé èrè tabua ló ń bẹ débi wípé gbogbo wàhálà tí ń bẹ ká máa fọwọ́ wú ẹ̀gẹ́, ká máa fọwọ́ yan gàrí, ká máa fọwọ́ ṣe gbogbo ohun tó jọ mọ́ nǹkan oko, ó ní ẹ̀rọ ìgbàlódé táwọn òyìnbó yìí tí wọ́n ń lò. Ẹ wá dákun, fọ́nrán tí ń bẹ ní ìkànnì wa tòní, ẹ bá ń pín. Ẹ bá ń pín kó kan lé kó kan oko, ẹ bá ń pín kó dọ́dọ̀ gbogbo àwọn ìjọba wa lórílẹ̀‐èdè adúláwọ̀ kí ìgbésẹ̀ kó lè wáyé lórí gbogbo ìgbà ọ̀tun èyí táwọn òyìnbó táwọn náà ń lò yìí. Bẹ́ẹ̀ bá dẹ̀ wò dáadáa, ká gbin nǹkan ọ̀gbìn, ká gbin ìrẹsì, ká gbin gàrí, ká gbin ẹ̀gẹ́, ọ̀dọ̀ wa ló ti wá nílẹ̀ adúláwọ̀ ń bí, especially nílẹ̀ Yorùbá. Ká gbin nǹkan làwọn bàbá wa ni wọ́n fi bẹ̀rẹ̀, ṣùgbọ́n nígbà tó ti di ayé ọ̀làjú, tó ti di ayé máa lo nǹkan tó jọ mọ́ ẹ̀rọ ìgbàlódé, àwọn ìjọba wa wọn ò ṣe mọ́. Ní báyìí màá fẹ́ ká fojú wo fọ́nrán yìí dáadáa, kẹ́ wo bí àwọn òyìnbó bí wọ́n ṣe bẹ̀rẹ̀ iṣẹ́ lórí ká gbin ẹ̀gẹ́ títí dé orí nǹkan tí wọ́n lè fi ṣe bíi gàrí, bíi fùfú, lóríṣiríṣi bẹ́ẹ̀ lọ. Ẹ farabalẹ̀ kẹ́ ẹ jókòó ti fọ́nrán yìí kẹ́ ẹ wò dáadáa. Bẹ́ẹ̀ bá tí wọ́n bá mi wò tán, ẹ má gbàgbé láti bá mi share rẹ̀, láti bá mi subscribe, láti bá mi pín káàkiri orígun mẹ́rẹ̀ẹ̀rin àgbáyé at Sanfatis Radio TV. Ẹ ṣé gan ni.
Mechanized. Farmers use specialized cassava planters that can simultaneously create furrows, place cuttings, cover them with soil, and press the ridges, all in a single pass. Such machines can plant 1 to 2 hectares per day, significantly reducing labor and saving time. After planting, a light watering may be needed if the soil is dry. Within 7 to 10 days, the cuttings will take root and sprout, beginning their gradual transformation into full-grown plants. An interesting fact is that the long, pointed lobes of cassava leaves are sometimes mistaken for cannabis, a surprisingly common misconception in both rural and urban areas. With proper cultivation techniques, cassava plants can reach a height of 1.5 to 3 meters, with vigorous root development that leads to high yields at the end of the 8 to 10-month growing cycle. This marks the foundation for a bountiful harvest, completing a journey that began with humble stem cuttings. At large-scale cassava farms, modern machinery is brought in to streamline operations. On wide, flat fields lined with neatly arranged rows of cassava, specialized harvesters move steadily along the beds. At the front, rotating blades swiftly clear the mature stalks. Immediately behind, a set of digging blades sinks into the soil, gently lifting the entire root system and pulling out clusters of cassava tubers. As the machine completes a row, the cassava plants vanish, leaving behind loosened soil and exposed roots near the surface. Workers then step in to collect any remaining tubers by hand and place them into large baskets or sacks positioned along the rows. Once full, the sacks are hoisted onto waiting trucks at the edge of the field. The entire process is smooth and efficient. Each pass of the harvester can save hours of manual labor, dramatically increasing harvesting productivity, especially during peak seasons. In smaller farms or areas with sloped terrain, hard soil, or irregular planting patterns, cassava is still harvested by hand. Though more labor-intensive, this traditional method can still be highly effective when done correctly. In loose, well-aerated soil, farmers can uproot entire cassava plants by hand without the need for hoes or crowbars. They then use specialized knives to separate the root clusters from the stems and gather them into baskets or sacks. It's a physically demanding task that requires strength, patience, and technique, especially under scorching sun or in hardened soil. In some regions, farmers first cut the stalks, then use a digging tool to lever the root base out of the ground. Once lifted, the roots are shaken clean, separated from the cluster, and placed into containers for transport. And when the trucks are finally filled to the brim, they roll away from the fields, marking the end of a fruitful harvest season and the beginning of a new journey, as these soil-covered cassava roots are transformed into pure white starch, ready to serve the food and industrial sectors. As soon as the trucks arrive at the factory, the cassava roots are unloaded at the receiving area and temporarily stored in a holding yard. Depending on the scale and capacity of the facility, the plant can handle up to several thousand tons of fresh cassava per day. At this stage, a preliminary inspection is carried out to remove damaged, rotten, or heavily contaminated roots before entering the processing line. At this stage, the raw cassava roots are divided into two main processing streams, depending on their intended end use. One portion goes through the dry processing route, where the cassava is thinly sliced, typically to a thickness of 3 to 5 millimeters, to facilitate faster and more uniform drying. It is widely used in the animal feed industry due to its high energy value and also serves as a key input for fermentation-based industries, such as the production of bioethanol, vinegar, organic acids, and various other bio-based products. The other portion is directed toward further processing into refined cassava starch. From the storage yard, an automated conveyor system continuously feeds the selected roots into the cleaning section, marking the beginning of a fully enclosed and high-capacity processing line. From the receiving conveyor, the cassava is transferred into a continuous washing system, typically a horizontal drum washer. This machine operates by rotating while internal spiral paddles and high-pressure water jets work together to remove all soil, sand, mud, and the thin outer skin from the surface of the roots. As the drum spins, the cassava roots tumble against the rough inner surface and against each other, causing dirt and skin to peel off naturally without the use of chemicals. In industrial processing, cassava roots are not completely peeled as they are in traditional methods. Instead, they are thoroughly washed and mechanically cleaned to remove dirt and the outer skin, allowing for maximum starch retention. As a result, a certain amount of cyanogenic compounds, primarily linamarin, may still remain in the roots, especially in bitter cassava varieties. And to eliminate this natural toxin, we must now take a closer look at the critical processing steps that follow. After washing, the cassava is passed through a manual inspection stage. Here, workers remove any damaged, bruised, or diseased roots that machinery might not detect accurately. The selected cassava is then either cut into smaller pieces or left whole, depending on the requirements of the next step, grinding. At this stage, the cassava is fed into either a roller crusher or a high-speed blade grinder, where it is crushed into a pulp. This mixture consists of starch dissolved in liquid and fiber that has not yet been separated. This is a crucial step that breaks down the cellular structure of the roots, allowing for the maximum release of starch from the raw material. The pulp mixture after grinding, consisting of starch dissolved in water and undetached cassava fiber, is transferred to a centrifugal or vibrating screening system, depending on the technology used by the factory. In a centrifugal sieve, the mixture is pumped into a high-speed rotating drum covered with a fine mesh screen. The centrifugal force pushes the mixture outward toward the screen, allowing the fine starch and liquid to pass through the mesh, while cassava fibers and larger impurities are retained and discharged separately. The separated fiber doesn't go to waste. It's collected and used as rough animal feed, as it still contains a small amount of starch and beneficial fiber, making it a nutritious meal for our cows. Do you agree with these, Moo? The next step is dewatering. Various methods are used depending on the scale and level of automation of the factory. At medium and small-scale facilities, a filter press is commonly used. In this system, starch slurry is compressed under high pressure between thick filter plates, effectively removing most of the water from the mixture. The result is a semi-dry starch cake with a moisture content of around 40 to 45%, which is soft, white, and moldable. This semi-finished material is essential for the subsequent drying process. Although the filter press operates in cycles, it is easy to maintain, simple to operate, and well-suited for medium-capacity production lines. In large-scale industrial factories, where high output, continuous operation, and full automation are required, the dewatering process is typically upgraded to a rotary vacuum filter. This equipment uses a rotating drum combined with vacuum suction to continuously extract water from the starch slurry. As the drum rotates through the starch tank, a thin layer of starch adheres to its surface and is gradually dried by suction through a filter cloth. This is also a critical stage for removing most of the natural toxins found in cassava roots. After grinding, cyanogenic compounds are released and dissolve into the water. Through continuous steps of fiber separation, filtration, and dewatering, the majority of hydrogen cyanide is carried away with the liquid waste, significantly reducing the toxin content before the drying phase begins. During the dewatering process, a large volume of wastewater is generated from stages such as root washing, grinding, sedimentation, and filtration. This wastewater contains residual starch, organic matter, and suspended solids, which, if not properly treated, can cause serious pollution to surrounding water sources. To manage this, factories typically implement multi-stage wastewater treatment systems, including primary sedimentation, flow equalization, biological treatment, and final disinfection. Some modern facilities also incorporate biodigesters, which recover biogas from sludge, reducing emissions while generating renewable energy to power the production line. This is a key factor enabling the cassava starch industry to grow sustainably and in an environmentally friendly manner. Meanwhile, the semi-dry starch is fed into a flash dryer, where high-speed hot air rapidly evaporates the remaining moisture in just a few seconds. The heat source for this drying system typically comes from biomass burners, coal, firewood, or gas, combined with automatic temperature control systems to ensure energy efficiency and consistent product quality. The result is a fine, white cassava starch powder with a standard moisture content of less than 13%. After drying, the starch exits the flash dryer at a high temperature and must be cooled immediately to preserve its quality. A forced air cooling system is used, blowing controlled streams of cool, filtered air through the starch as it moves along the conveyor. Once cooled, the starch passes through a sieving system, typically a high-frequency vibrating screen or a roller-type disintegrator. These machines are designed to gently but thoroughly break down any remaining agglomerates formed during drying. This step ensures the starch has a fine, uniform texture, removes any oversized granules or residual impurities, and prepares it for precise and consistent packaging. Once the starch meets quality standards, it is transferred to an automatic packaging system. Depending on demand, the product is packed in 25 kilograms or 50 kilograms bags, or in jumbo bags weighing up to 1 ton, suitable for both consumer markets and industrial processing. From humble soil-covered roots to refined, pure white powder, through human hands and modern technology, a remarkable journey unfolds, producing starch that nourishes people, powers industries, and connects the world.